This is Mirza Abrar Beg. This lecture is an introduction about embedded systems. This lecture is part of a series of lectures that I will be delivering after this. This lecture will give you introduction about embedded systems. Then we will focus on microcontrollers and especially big microcontrollers, and there will be series of lectures afterwards. So let's start from this lecture. What we will be dealing in this lecture will be definition about the embedded system. We'll see some examples. Then we'll see parts of computer, essentials of computer, and we'll talk about microprocessors and microcontrollers in general. Then we'll talk about big microcontrollers, and then we'll see big 32 series of microcontrollers. If we talk about embedded system, what is embedded system? Basically, if we see appliances at our homes, like a refrigerator, television set, air condition, and so on. We give the example here, we give the example of a refrigerator. For example, let's say we have embedded system in our refrigerator. What happens when we open the door of refrigerator or the freezer? We have set some temperature, medium, cool, or high, or low. So things inside the refrigerator, they remain at that temperature. When we open the door, outside air disturbs the temperature, and then our embedded system start working behind the scene. What it does, it sends the signal to compressor, and then compressor will kick in, and it will try to bring the bring the temperature to the required temperature. And then when it happens, then it will stop. It will make compressor will be stopped, and then it will control it. So this is an example of a embedded system. Here, another example of embedded system is water reservoir and overhead tank. If we have an embedded system in place, as you see in this example, we have sensors level at the overhead tank, and then we have a pump. Actuator output is going to pump. Whenever the microcontroller or the embedded system senses that level of the overhead tank goes low, then it sends a signal to pump, and pump will start pumping the water from reservoir to the overhead tank. And once the overhead tank is filled, the level sensor will send the indication, will send the input to the embedded system, and then at that time pump will be stopped by embedded system. This is about the car. We have different buttons inside the car. We can roll down the window with push button, and we can have a lock control, and we have sometimes we have if we have some door is not properly closed, that operadome sensor will send the signal to microcontroller or embedded system, then we'll see indication that some of the door is not closed. So we have this example of the car of embedded system. How the embedded system is formed? It is formed by computer system. Okay, so computer system has CPU, central processing unit, which is the brain of all computers, and it's used in different computations. But CPU does not work alone; it has some peripherals. What about the microcontroller? Microcontroller is sometimes called microcontroller MUC or MUC. MCU is like a small computer within a chip. which has memory and IOs and so on. So microcontrollers are these are the small, you can say the small computers. They are designed for embedded system applications. Right, whereas microprocessors, they are designed for personal computers and supercomputers for complex tasks and applications. Let's see. This picture tells you about the microcontroller, which has everything in one chip. It has a CPU, it has a memory area, which is a RAM, ROM. Okay, so this is the memory area here. It has timers, it has serial communication, it has a clock signal generator, oscillator, it has A to D converter. Okay, it has different IO, digital IO ports, input output ports, it has power supply section and so on. So everything is built in one chip. So this is called microcontroller. Let's talk about what are the main or essentials of computer system. We know we have a CPU, which is central processing unit, which is connected with memory sections. Memory section has two parts: data memory, whereas as well as program memory, and it is also connected with input and output ports. So inputs can come from outside world, then it comes to CPU, it processes this in the request, and then it keeps the data within the memory. The program is stored into the program memory, which will process the data, and then processed data will be sent back to the outside world through IO ports. This is another block diagram. So as you can see, computer system CPU requires these peripherals: RAM, ROM, printer, disk, IO monitors and keyboard and so on, IO ports in general we can say. And it requires connection to these ports, which peripherals, which is an address bus, which each peripheral has its fixed address. So address will come on the address bus, and we have a control signals which sends the signal to read or write from the CPU, and we have a data bus. Data will be sent or received through data bus. We know that we have two types of computer hardwares: von Neumann and Harvard computers. Von Neumann has same memory. Memory is the one for data as well as instruction, and it has same set of buses, address and data buses between CPU and memory. It's the same for address and same for same address and data bus for instruction memory, and same address and data bus for data memory. Whereas in Harvard architecture we have separate memories, separate data memory and separate program or instruction memory, and we have their buses are also separate. We have two sets of data and address buses. One set is for data memory and one set is for program memory. Here we can see in the block diagram, on this left we have von Neumann system, whereas on the right we have Harvard computers. As you can see, in Harvard computers we have separate program memory and their separate address and data buses, separate data memory, separate data address bus, and separate address and data buses for IO ports. Whereas in von Neumann architecture, these buses are shared with data memory, program memory, as well as its IO ports. If we talk about the programming model, we have RISC and CISC. RISC is reduced instruction set, and CISC is complex instruction sets for the microprocessor. If you compare between the two, RISC is simple and small instruction set, require fixed instruction format, simple address mode, pipelining instruction executions, and more than 95% is executed in one clock cycle. whereas 6 has a complex large instruction set, irregular instruction format, complex address modes, and we could have pipelining instruction and execution. And provides small CPU registers. RISC provide large number of CPU registers. We have in RISC separate data and program memory. In CISC we have combined data and program memory. Most operations are registered to register, whereas in CISC most operations can be registered to memory. It takes shorter time to design and debug, whereas in CISC we have longer time to design and debug. Okay, we see microcontroller versus general purpose microprocessors. Intel has introduced the microprocessor. It's called Intel's x86 family. We start with 8086, 2868, 643, and 10 Pentium, and so on. Or Motorola had this Power PC family. You can see that microprocessors, they do not contain RAM, ROM, and I/O ports on the same chip. System designer, you need to use these general purpose microprocessors, Pentium Power. They must add RAM, ROM, I/O ports, and timers externally. The advantages versatility and flexibility, and disadvantages, they're more expensive. Here we see the comparison between data between general purpose microprocessor system and microcontroller. As you can see on the left, this is a computer systems. CPU is connected with the buses with the RAM, ROM, I/O ports, timers, serial ports, and so on, whereas microcontroller has within the same chip all these peripherals within the same chip. So we can say that microcontroller has a CPU, it has RAM, ROM, I/O ports, and timers, and all embedded in one single chip. Its advantages is fixed amount of on-chip RAM and ROM I/O ports makes it ideal for many applications. Disadvantage, you cannot add external memory or I/O timers to it. So now we're talking about embedded system. For embedded system, we choose a microcontroller. They are designed for embedded system, and they are designed for simple tasks. So first criteria, we must check whether we need 8-bit, 16-bit, or 32-bit microcontroller. Okay, and then secondly, we see the speed of execution, whether we want fast execution or slow execution or moderate. Then packaging comes in play, whether we have DIP or QFP or TQFP, or which type of packaging we can adopt, and how much power is required for our system, and RAM and ROM on chip, how much RAM and ROM should be on the chip. Here you see the QFP and DIP. Another criteria is number of I/O pins and timers on the chip, cost per unit, and ease for upgrade of higher performance. Second criteria, we must have the ease of development products around it. So mostly some tools are available. Sometimes the debugger, assembler, or compiler, they're available freely, so that will reduce our cost. Also, if we are choosing some microcontroller, we make sure that it's readily available in our local market. Now we talk about history of PIC microcontroller. It started in 1989 with Microchip Corporation. It introduced 8-bit microcontrollers called PIC. It stands for Peripheral Interface Controller. It had a small amount of RAM, few hundreds of bytes on chip ROM, a timer, a few I/O ports with 8 pins each. Their features now, as the time goes by, they increase. They advance into their microcontrollers family. We talk about PIC32 features. The low-cost, self-contained. It has everything in it that is required. 32-bit Howard architecture, pipeline, RISC, single with a reset and multiple interrupt factors. Here you can see the PIC family is starting from 8-bit all the way to 32-bit microcontroller. This is the overall picture of the PIC microcontroller. This will conclude our introduction about embedded system and microcontroller, and we have introduced PIC 32 microcontroller. In next lecture we will start from PIC 32 microcontroller, and we'll see in details all this, its peripherals and all different parts of, and what are the features of PIC 32 microcontroller. If you like this video, please share it and subscribe it to my channel, and if you dislike it, also send your comments for the improvement, so next time we can improve. Our next lecture will be about PIC 32, and then after that we'll go into the programming of PIC 32 microcontroller. Thanks very much.